Welcome back to Howdy Partner. We got a lot of new friends here today. A lot of new friends. All new friends, actually. I think I'm the only one that's ever been on Howdy Partner today before. That's amazing. This is a world first. It's not that big of a deal because this show hasn't been on very long. But I'm Aim Grabelli. I'm a partner solutions architect here at AWS, joined by Ryan Scott Brown from Trek10, Alex Wood from the AWS SAM team. So this is going to be really cool to have a service team and a partner on together. I think that's going to be really neat. And brand new co-host, Eric Vasquez. Eric, do you want to kick us off? Tell us all about Howdy Partner. Who should be watching? What is the show? What is this crazy thing that you just happened to stumble into if you're watching right now? You there, Eric?
A little delay there. Sorry about that, guys. So my name is Eric Vasquez. I'm a partner solutions architect with AWS. I'm going to be your co-host for today. If you aren't subscribed to the channel already, I recommend you do so, as we're going to have more partners as time goes on.
Yeah, that's great. Exactly. So this is a show all about AWS APN partners, right? This is all about all the partners, both. We've got two types. This is something that I don't think a lot of people know about. We've got ISV partners, which are like technology partners. These are partners that provide a solution, a product packaged for you that you can subscribe to, as a SaaS, all kinds of different products. Ryan here actually is from the other type of partner, a consulting partner. Sometimes we call these SIs. This is somebody, and actually, I should just have you take this, Ryan. And this is your chance to give a little plug for Trek10 too.
Yeah.
What do you all do?
So we are a all serverless and IoT AWS partner. We just got Premier status, so we're a Premier consulting partner with that focus on serverless and IoT. So we spend tons and tons of time on interesting problems in AWS. Some of that's migrations, some of that's rewriting systems, refactoring systems, and some of that's going to be new builds. And as kind of a mix with that, we also do training. So bringing your team along on your journey from data center to something in AWS to everything in AWS to cloud native.
This is something the distinction I like to make between the two types of partners, right? ISVs, their big, centerpiece is their product, but SIs or consulting partners, their big centerpiece are the people, right? I don't know if that's a fair assumption, but that's how I look at it.
I mean, we've got tools. We use a lot of different existing stuff, and we have a bunch of custom tools as well. But the centerpiece is always people. So when you start and you think something's an engineering problem, and then you ask about 4 questions, and it turns into a knowledge gap problem, a strategy problem, a business question. Like, all of these are ultimately like business and people problems that you can either have a technology that makes that problem less severe or more severe. There are different routes you can take. But it all comes down to the people in the business.
Totally. I think that's a great way to put it. Cool. Alex, tell us about the SAM team. What do you do for the SAM team?
Sure. So hi again. I'm Alex. I'm a senior engineer with the Serverless Application Experience team. And yeah, so we build open source tools to help developers more easily build, maintain, deploy serverless applications. So yeah, what you'll probably know us for is for AWS SAM, the Serverless Application Model, Transform, and CloudFormation, as well as the AWS SAM CLI, which builds on top of that to help initialize projects, build them, deploy them, local testing, log analysis, the whole deal. So recently, we had our GA launch of the AWS SAM CLI. So we have both of those products now in general availability, high operational stability state. And yeah, I think today we're going to do a little bit of a tour of what's changed over the last few months, and should be a lot of fun.
Yeah, I'm sure Ryan, you'll have a lot of questions as a user of the SAM CLI and the SAM templating system too. I'm sure you'll put Alex on the spot, hopefully.
Oh yeah, I mean, I'm overall a huge fan of SAM. I've been using it for quite some time. Before it's been GA'd, maybe has been in a couple projects that have made it to public facing. But I mean, the GA release for me is not it hasn't broken anything that I use. It's not making any like huge changes where I now have to go back and do stuff. It's just blessing that existing SAM toolkit that I've been using and has been super reliable already. And, put that big 1.0 bow on it.
Totally.
Yeah. That's exactly what we've been going for, is to try to, like the small breaking changes leading up to GA, we really tried to space them out, do it gradually, plenty of announcements, but we got to a point where we're ready to say, we've got more that we're going to be doing for it, but now we can say that you can start using this and upgrading it with confidence, and know that you're going to have a reliable developer experience. So that's what we're really excited about. We think I think it brings a lot more customers to the table where this is now a tool that can be really a big centerpiece of what you're building.
Yeah. So, as is Howdy Partner tradition, right? We're always here to teach you something or to teach you about something, either one of our partners' products, or in the case with Ryan and Alex, we're gonna dive, kind of superficially the 100, 200 level or the beginner intermediate stage first. And then Ryan is going to take us all the way into building a CI/CD pipeline and some crazy things too that you might not think that SAM is used for often. But these are areas beyond the beginning serverless steps of, I can hook up some lambdas to an API gateway with S3 as storage, Dynamo as my data tier. I think lots of people have seen that before. Ryan's got some really exciting things today that.
Yeah, I think the way that I would summarize it is SAM, gives you those tools for serverless stuff, so your lambdas, all that, and that's great. But because it's integrated with CloudFormation and has a bunch of, frankly, non-serverless transforms that are very useful, you can really take, anything that you're doing in AWS, and SAM can make your life either a whole lot easier if you were writing the AWS Lambda function resource, or at least somewhat easier if you're not even using anything serverless. It just makes your CloudFormation lifecycle a lot easier.
Yeah, that was one of the first things that I loved SAM for, was that I didn't have to figure out all these crazy IAM relationships between, my Lambda needs permissions to go create logs into a log. This back in 2016 when they figuring out that actually to log to a log group you have to write an IAM role. SAM just does all this stuff for you. That was way back in the day, one of the best.
For an interesting exercise, it can be fun to take a SAM template that you've deployed and to look at the transformed output. And even for a very small amount of code, a lot of resources get created to really help smooth over permissions. And one fun thing about SAM is we can generally do very well tightly scoped permissions that enable you to have minimum permissions throughout the stack. And there's even things like policy templates that are going to help you say, I want to have DynamoDB read and write access, but there's only one table in my application, so that's what I actually want access to. And there is a question in the chat that I think ties into this pretty nicely. So someone asking why use SAM instead of CloudFormation. So an interesting thing to keep in mind is that SAM is, it is a transform for CloudFormation. So you write CloudFormation with special resources and it outputs CloudFormation. It is essentially a superset. So if you added the SAM transform to an existing CloudFormation template, it's not going to do anything, but it is valid CloudFormation. So what it gives you is the ability to have different integrations. So you can have the integrations between I have an SQS queue, wire it up so that Lambda runs off of it with a lot less infrastructure defined.
Yeah.
As well as when you combine it with the SAM CLI, it can help you do things like build your source code off your development machine and then have it package and deploy on your behalf, rather than managing by hand things like make sure my code gets to S3 and then using that as your deployment base. So it builds on top of CloudFormation. It's not an either or.
I can tell that these two are so excited to start teaching you all about this stuff. I think we need to jump into some of these demos, but first, if you are watching right now, or in the future too, you can hit us up on social media if you have questions. But right now, live, if you're watching us, the beauty of Howdy Partner on Twitch is that you can ask us questions just like Morris Scaler did, and we will answer them. So please put questions in the chat. Eric and I will be watching. You also, I think in the case of Alex and I think in the case of Ryan, both some of their demos that they're going to show you today have some interactive moments where you'll get to pick. So be sure to put in what you want to see as we're going along. So Alex, you're going to kick us off for us, right? You already started, I feel like, but let's get over to you showing us what SAM is.
Let me get a window up here.
Yeah.
So what we're going to do, and maybe this can kind of help with some of the questions here, is I've got a blank folder, and we're going to start by going through one of the new features that we launched last year, which is an interactive workflow for the SAM CLI. So if I run the SAM init command without any arguments, it's going to give me a number of different choices. So we both provide a number of what we call quick start templates that give you some runnable examples or starting points for your application, as well as the ability to use custom templates defined in GitHub. And I think we're going to look at the custom templates a little bit later, because I think it has some fun applications. But we're going to start with a quick start. So I'm going to throw a first interactive thing out there, and this might put me in a little bit of hot water depending on the choice. But does anyone have any strong language feelings? There might be one or two I'm gonna veto just for my experience with them. But we have a lot of choices and a lot of demo apps in each language.
I mean, if you don't get anything from chat, I'm always.
Oh man, I knew that Mo was gonna drop Golang in here. Mo is.
All right, I'm gonna bring out the Golang. I've got a little bit of it, so let's see how it goes. I've got a little bit of Go experience. If it gets hard, I might jump out of it. All right, so we can take a Go example here.
Yeah, we got a few Go votes, so.
Yeah, we got a few Go votes, so we're gonna go for it.
No.
So it begins.
Wow.
Yes.
It's one of these streams, huh? Okay.
All right, so actually, this is a fun one. Like, let's go into an example of a new SAM abstraction that we've launched recently as well. Step functions built directly into your template. And I think this is actually going to be a good illustration of kind of what you are capable here, what you are capable of as far as SAM versus CloudFormation. So I'm curious if anyone in the chat has made a step functions definition in CloudFormation before. But let's go take a look here at the template that just got generated. So now we have the AWS serverless state machine resource definition. And what it does is it provides for you actually the ability to define your step functions directly in YAML inside your template as you wish, or define it as a JSON file. So what we have here is a sort of like a stock buyer app. It's kind of a very simple demo where you have a number of states around, generates a random stock price, makes a very simple buy-sell decision. But it also demonstrates things like doing a DynamoDB put item directly to DynamoDB without a Lambda step in the middle, which I don't know if Richard has showed up in the chat yet, but he's a big fan of direct API calls out of CloudFormation API Gateway and similar. So it's making him happy.
Wait, are you conjuring Richard Boyd? You have to be careful.
He said he was going to be around the chat, so
no.
dangerously.
Oh no.
But
I'm just kidding. I
so
love Richard.
what we have here is there is a another interesting integration that you get with the step function support in SAM is you also can have events that trigger your step function workflow, much like you can have events that trigger a Lambda. So say, for example, you have a scheduled event where you can say, run this every hour. Or maybe we're going to say every minute, just to make it a little bit interesting. And we basically just have a small set of functions here for the stock checker, the stock seller, the stock buyer, a very simple table. And in this case, which kind of goes back to the traditional way of doing things, you have the ASL definition for resources that are going to exist inside your template, inside the JSON, and it's going to go ahead and combine that for you with the definitions that you provide in the template.
Yeah, so I can tell you, like,
is this pretty straightforward? And you have right there at the end the direct write to DynamoDB event definition where it sets all that up for you. And that's the basic app. So if we show one of these
your screen is frozen.
Yeah, Alex, you're not.
The screen is frozen.
Yeah, I think
you're still on your terminal.
I think you're the only hands on the demo right now. So we will try that again.
All right, we're going to do a quick review. Can people see it now?
There we go. Yes.
We are enjoying live demos right now.
That's right.
All right, so let's do the quick version, reviewing what I just talked about. So we've got some code here. This is a real simple stock demo. We literally just do a random seeding for stock price 0 to 99. Buy if it's below 50, sell if it's above. Going back, we've got the template here. So if we do the quick review, you'll notice we have things like definition substitutions that you can put inside the JSON. So this is actually using the model of you have a state machine JSON definition, which you can import, or you can define it in YAML. It's your choice. But the nice thing you get from this is if you go to the state machine, you'll find that you can have all your different events much in the same format you have, but you can also have substitutions built into your JSON that will be resolved at the time we build the template. So a little bit of fun. I haven't tested the Go Stock Trader demo, so we're all going to experience this together. If I go into our Go example, and I'm going to need to share my window again, I think. I see what's going on here.
All right.
All right. Is everyone able to see my screen now?
Yes.
Getting some verbal confirmations.
You are all good.
You are great.
Not frozen here. Not frozen here.
Oh, you're moving.
All right. We're doing it live.
And grooving.
All right. So if we want to build this Go application, it's as simple as running SAM build. And we have, for all of the officially supported Lambda runtimes, both the ability to build in a container for many of them, although interestingly not for Go, because you don't need it. Go has pretty good support for building in your target architecture. And we also have a new guided deploy option. So we're going to go ahead and deploy this now. Call this Go Stock Checker. We use US East 2 because I like it for demos. And it goes through a number of questions like, do you want to confirm your changes each time you deploy? Are you going to allow it to create IAM roles on your behalf? You can save arguments such that next time I deploy, I just run SAM deploy without any arguments. And you'll even notice I never even dealt with an S3 bucket for the packaged artifacts in my code. using the guided deployments, we handle that on your behalf if you don't want to specify it. So it makes a lot of things simpler. So we're going to go through the live deployment. We're going to see how this turns out. And I'm going to pull up a screen in a moment that's going to have this.
Can we just stop for a second and admire the really pretty output?
Yeah.
Really beats
cloud
refreshing. Yeah, it beats refreshing the CloudFormation console for sure.
It does. And you know, if there's any bugs in this init template, we will find out in real time with interactive output.
Yeah, I think this is something, you know, interesting maybe to point out to those new to Sam. This is actually from the CloudFormation engine itself, right? It's just pushing the logs from CloudFormation that you would get.
So this is actually a good point to the question about if there's kind of like SAM versus CloudFormation for greater control. So a couple angles to that. So one, I think that SAM actually provides pass-through to kind of like the vast majority of the functionality you're going to care about. So there's generally not going to be a large gap between if you went to deal with these resources at a low level. Like they're meant to be very flexible, simple abstractions. Like we're not trying to take away customizable abilities from you. Although if you do choose to like define your own API gateway resources, you still have the ability to reference that inside your Lambda functions. You don't have to use all the different serverless constructs with each other, but they tend to go together quite nicely. It helps kind of simplify the experience. So I mean, I think SAM is suitable for all the way up through production level applications. It's not like something that you kind of mess around with to get an initial demo and then you have to kind of drop back out of it. It's actually fit for purpose.
Yeah, and I would echo that for sure and say that like the ability to drop out to CloudFormation at any time is really nice, because if I need to go and like adopt a resource into my stack, I can actually do that with a SAM template. So like if I need to adopt in an existing thing using that CloudFormation adopt resource feature because something was made manually and I need to pull it in, SAM didn't have to implement that separately. I just got to use the CloudFormation feature for free.
All right.
So you get tons of that stuff.
Let's go ahead and go check out what we just made.
You already did that one. You're just repeating now, Alex. Come on.
Go only has like 3 jokes.
That's true. Fair enough.
So if everyone's able to see this, because we run every minute, we've already had our first successful execution. And you can see, you know, checks the stock value, generates a 60. That means it's going to sell. So it builds out a transaction that gets recorded by the next step to DynamoDB, and we're good to go. And, you know, we can do new executions. This time it's going to buy because the output was 13. But, you know, that was a pretty simple step functions based example. And you can kind of see we went from an empty folder to running step functions in a few minutes, largely spent with me talking and walking through the code.
Let me, not to totally derail us here, Alex, but could you tell the audience a couple things that you would use step functions for? Like, why would I need step functions and not just, you know, like the Richard Boyd method of calling lambdas?
Sure. So, so typically, like, I think, not to speak for him in all cases, but a lot of the Richard Boyd model sometimes is like, if you're going to have, say, an API gateway call, which is going to start an SQS-based workflow, why have a Lambda in the middle when you can just kind of like directly translate it and start that workflow? And that's completely valid. Where step functions then comes in, actually much along the same lines, is when you have more complex workflows. So if you go back to this example here, you could imagine, for example, saying a number of different failure states. So you could imagine, I try to buy a stock, but you know, I'm actually buying a stock now, and I do the transaction with an interface that actually allows me to perform the stock, and maybe it's a killer fill order. I've got my bid limit and it's not going to get filled, and so I need to do my calculations again. You could also imagine for long workflows like I'm processing data and I need to deal with, all right, do an ETL job, do my first passive analysis, do some sort of transform, maybe make sure you've wired it to all the different output sources you're trying to go to. Anything where you're doing orchestration with multiple states is where step functions can come really in handy.
And also you get better visibility into where each of those steps is at. Whereas if you work with SQS, you've got an SQS going to a Lambda, going to an SQS, going to a Lambda, and the visibility is just not there for individual transactions. And that's part of what you get with step functions.
Not to give too many spoilers, spoiler-free channel, but Ryan has some step function usage in his demo too. So this is a good time to ask questions up front about step functions so that Ryan can tell us a little bit more later on.
So because we used Go, there's a couple things, and because we used the step functions demo, there's a couple things we didn't cover that I wanted to do a quick pass over. So as someone who is incredibly biased, my start with Lambda was I wrote the Ruby runtime for Lambda and then instantly had to start working there. So I'm going to use the Ruby runtime now to show a couple of other interesting SAM features. So we have basically a hello world example in this case. And one interesting piece of functionality is the ability to build inside a container. So where this really comes in handy is when you start to talk about things like dependencies that have native extensions, which are fairly common. So if you were to do a build on a Mac laptop, say like I'm on, and you're deploying to an Amazon Linux-based execution environment, what you'll actually find sometimes, depending on your language, you're going to have different types of runtime issues. In Ruby, it'll show up like you don't actually have that dependency because it matters the target architecture you're building for. Interestingly, Go doesn't need containers because you can tell Go what your target architecture is and you're good to go. But in the case you're good to go, it really is the same joke, isn't it? I'm so sorry.
Yeah, at least Ruby has a couple real gems.
Hey. Oh, no.
All right, I'll see you all. Thank you.
So,
yeah, it's been good.
So, but like if you have native dependencies, the ability to build inside a container that is going to match the environment you are going to be deploying to really comes in handy. What we can also do is we can do local invoke commands where it is going to run inside a Docker image, which is a very high fidelity copy of the Lambda execution environment, and you can go see how things are going to run. So this is a basic working example. It's going to give me a hello world. If I want to do something a little bit more fun, like maybe my code is wrong. And it's raising an exception. So I can do a quick build of this, and in the context of I'm writing code and maybe that error is something a little bit more substantial than me just raising for fun, although maybe I debug in a strange way and I'm just doing some local development cycles before I go through the effort of starting a CI/CD pipeline, which might discover this issue and have a little bit of a slower cycle of feedback as it performs all the build steps, and maybe you go through a number of tests before you see it. I can do the local invoke, and in the case now where I've got a bug in my code, I can just get that really quick feedback of, look, you're raising a runtime error. What have you done? So it's another little piece of handy functionality for just, being able to develop on your machine. Well, you also have the ability using guided deployments to really easily set up developer stacks and run in AWS and Lambda as well. So it's a really nice dichotomy, a really nice set of choices. And I think one of the big advantages of serverless really is since you're only paying for what you use, you can essentially, in many cases, deploy your true production stack. And you're only like if you're doing some small testing, you're not going to be racking up a significant amount of resources to do your tests.
Yeah, we hear this
you're
time.
also skipping that cloud round trip too.
Yeah,
you're not going all the way.
I was going to ask Ryan at Trek10 because I've heard time and time again from ISV partners, at least in the serverless space. Like we've had Stackery on and we've had serverless framework on the program, and both are pretty big advocates for local testing is cool and it's great for teams that are used to working locally, right, before they kind of get more into the world of serverless and more comfortable with it. But ultimately, just deploying and testing in the cloud just because it's so cheap is the way that some teams end up going.
I would be on board with that. I'm definitely on board with that as well. Because, I mean, at the end of the day, it is a high fidelity copy of the Lambda execution environment, but I think when you have the ability to run in the real deal, you're necessarily going to have higher fidelity testing. And it's kind of one of the superpowers of serverless and CloudFormation together. Like this has always been a classic advantage of CloudFormation too, is you have a defined copy of your infrastructure and you can set up true test stacks, true developer stacks. And now with serverless, it's even more practical to do it at every developer level.
Yeah, I mean, I think the best thing that you can do is reduce that time from I've written a little bit of test code up to the highest fidelity environment you can afford. So when you're, doing some basic print debugging, you have kind of one event down on your laptop that's ready to just invoke your function for a simple test. That's great. That's the level of fidelity that you're looking for. But if you are using a lot of other services, so like let's say you're taking in events from many scenarios, right? So let's say you're taking in EventBridge, SNS, and direct invoke events, right? It's going to be hard to simulate all of those locally with the right fidelity. So the way that I usually recommend when you have a lot of event sources is basically breaking out your event inputs and your business logic. So this is, every time you've ever used like Django or, Rails or any of these frameworks that are web frameworks, they have already taken all of that event input handling and put their own layer in between, and then they're giving you the request object.
Funny that you mentioned that.
So, I have a quick question for you, Ryan. Just for those of us that aren't too familiar with what fidelity is, what you meant when you said that, can you just explain that a little bit better?
Yeah, it's sort of the level of difference between what you're doing and what will happen in production. So an extreme low fidelity environment would be, I am going to write down on paper the output of each line of my code to validate that my logic is correct. And for some really tricky things, stepping through pieces of code line by line yourself can really help you understand. But the fidelity on that is really, really poor because you're a worse compiler than your compiler, right? So the worst fidelity would be, replicating your code's actions on paper. The best fidelity is having a sample of real data from prod and throwing that event into your system in an integration test. So you have an incoming event that looks just like what you get in prod. It's hitting the same API gateway that your customers hit in prod. It's going through the same exact Lambda runtime that your customers hit in prod. It's hitting the same code base your customers hit in prod. It's hitting the same event handling, the same queues, the same IAM roles. That's a real high fidelity environment. So if you have a SAM template that represents your application or your service, you can have a super high fidelity environment for just pennies per invocation, right? Because each Lambda, what's the Lambda cost? It's $3.50 per million invokes or $1.25 per million invokes.
I can't remember at the top of my head, but it's pretty low.
It's extremely cheap, And when you think about it, why would I spend all this time building up really high fidelity mocks so I can develop locally when I can have the highest fidelity environment available at the same cloud provider, the same resources, the same template, the same everything. And it'll help
20 cents per million requests.
At something ridiculously cheap.
There's a little bit more for the memory duration, but it essentially boils down to the per request billing is 20 cents per million at the time of recording.
Yeah, and so if you're looking at your your integration tests, maybe you have a suite of 1,000 integration tests that each throw a couple events. So you're looking at nano dollars, I guess, is the unit that you're looking at for cost per run. So
realistically, generally within the free tier, if you're talking about a developer stack, yeah.
Yeah, I mean, really, it's to me a real benefit of serverless is that I don't have to do all of this extra work to get that really high fidelity environment set up. Whereas if I'm on-prem and I want a high fidelity environment, it's like, okay, I've got to buy the same OS that's running on the servers. I've got to get that in a VM, and I've got to make sure the VM has the equivalent network interfaces in memory. And then I've got to make sure that my OS has the right patch level. And then I've got to make sure that my interpreter is installed the same way. Then I got to make sure that the automation that's setting up that server, assuming there even is automation, is also running against my server. I got to make sure that the security agents on that server aren't going to block the things that I'm doing because I don't have the security agent because I'm not paying for licensing per host for that for a dev environment.
I've already quit the team, Ryan. I already quit. Sorry, man.
Yeah, but you see how the distance between the prod environment in your AWS account for a serverless application is so much smaller than the distance for even just an auto scale application. There's still a delta there.
All right. Yeah, thank you for clearing that up, Ryan. Appreciate it.
What's fun about it is there's a joke on stream of I test on prod, but the fun thing is if you're doing these high fidelity developer stacks, you are testing on a prod-like environment. It actually, in a safe way, becomes a non-joke. You're testing in
ideally
what is prod.
Customer data.
Yeah, the only difference is going to be data. So put in stub data, put in your test data, and run a prod-like environment. So a fun thing that I saw mentioned was the idea of Django, Rails, Sinatra, Flask, tools like that do a lot of abstracting out to kind of give you just kind of the user-facing side of things. So if we go back to custom location templates in SAM, one that I have published is a Sinatra template that one of our SAs wrote the basis of around the time we launched the Ruby runtime, and I did some cycles on it. And if you look at the code I've got on screen, this looks no different than any other Sinatra application you're writing. We can templatize how does the Lambda handler translate API gateway events so that Sinatra can understand them and respond properly. And once you've done that, you're just writing code. And this application is running right now, and in a working state. It's kind of been the basis of a number of demos I've done. The idea of you can create for a lot of these web frameworks, for a lot of event-based frameworks, you can do the abstraction once of how you translate events, and then you're just writing code. And it works very well, in fact.
Yeah, I'll say this exists for a couple other frameworks too. I know we have one for Express, and I know the .NET team here at AWS spends a lot of time working with ASP.NET. I'm an old C# dev, and it hardly ever gets mentioned in the same breath as serverless, but there are a ton of AWS serverless tools for .NET.
Well, and if we go back to the earlier question about when you need fine levels of control, so one thing about this particular abstraction is we have to do a little bit of playing around with API gateways, open API definition to make this work. because essentially we tell the Lambda function, I'm capturing all HTTP requests in a single function, letting Sinatra do the routing in this case. So what you'll see is like all that API gateway functionality that we need here in this template, like we're able to go out and define all that detailed stuff. But when you come here and you're essentially developing the application, you can be laser focused on just I'm writing my code and maybe I'm updating the definition of my app table. And there are a number of demos I've given, say, at different conferences where you kind of start from this basis and you can write a lot of code in a very short period of time.
Or write a little bit of code and get to the same place.
True. And, when you have these well-defined APIs and you have kind of the behavior interaction with outside sources, it works really well in CI/CD pipelines. So C++ was asked about in the chat, and there is actually a custom C++ runtime that is available where it'll compile a C++ binary that interacts with Lambda, and it works quite well. So C++ is absolutely an option.
Oh boy, does custom runtimes open up a lot, man. Maybe too much. I'm a big, I try to avoid custom runtimes where I can, just because then I have the upkeep of a custom runtime, so there are downsides. Whereas when I'm using the Python runtime, I just need to say, give me the 3.7, give me 3.8, and that's all I need to specify. And then I can add my own layers on top. Whereas like custom runtime, you've got to have your own, compile and build layers for that. So it almost starts to look like a golden image pipeline when you're, coming from like a VM land. But
yeah. I think custom runtime thing is a really interesting piece, and to be honest, like and fair, there are a ton of shops that can't move off of certain languages, right? They just
no, I'd rather it be there than not.
Yeah.
I'm glad it's there, but when I don't have to,
right. Totally.
pass.
Yes.
For sure.
Yeah. I think they're simpler. If you are starting like greenfield on a project, I think there's some pretty solid choices to make from existing baked-in runtimes to Lambda.
I am a big fan of, especially for me, both the Ruby and the Go runtimes. I find myself using a lot. I think for me, like Ruby gives me the best productivity performance balance, and like Go is just screaming fast.
Yeah, I think the only thing that's missing from Go is a real good JIT.
Well, okay, now we're getting into language matters.
All right. So I think, is that the last of your demo, and we'll switch over to
I think so. I think that we covered a few things. If we have some time at the end and there are other interesting things people want to see, I'm definitely happy to play a little bit of live code. But there's definitely a lot of demos out there I can refer people to as well, where we walk through some different examples.
Yeah, and I feel like every AWS Quick Start nowadays has at least a couple Lambdas in there too. So there's plenty of like real world application stuff that people can see.
Yeah, totally.
So I will point out also, someone was asking about Haskell too. There is a community-made Haskell runtime that I could find on Google. I haven't tried it, but it is actually pretty reasonable to write your own runtime. There's a lot that goes into it if you want to distribute it, use it in production, especially if you're distributing it around things like error handling. But like the fundamental concept of writing a custom runtime is very reasonable to do.
Yeah, conceptually it's really easy. The hard part is always the maintenance, right?
And there's a lot of examples to follow if it's a thing you're interested in. But it's fun to try and understand more about how Lambda works.
Yeah, the wire format that you get events in is kind of cool.
So Ryan, you're going to actually take us through. So we've got all the getting started, how do I pick a language, all these things figured out, right? But now I'm a real development shop. How do I take serverless to the next level with Sam into automating deployments, doing all the things that like a team like yours would go out and do?
Yeah, I mean, so I'll definitely start with all the normal caveats of like if I could just do everything in a Lambda function, awesome. If I have to start, mixing, I have existing applications, I have other constraints. That's when we get that's when things get difficult, and that's kind of why people call me, right? So it's this demo is all going to be all about the CI/CD. So this is shortening that time between I have some code and I have it in either a prod-like environment or in real prod, and shortening the time that a human has to spend in that pipeline. So if, before you've done testing cycles where you're just clicking around the app, making sure everything looks good, that's time that you could have back and use an automated testing suite. If you're making CloudFormation change sets yourself and then having a teammate review them, you could have a robot do the making the change set and then let the teammate or you review them. So all of these steps, there are things that you can automate. There are things that you can make easier. All the slides, all the demo stuff is on GitHub. So you're, by all means, like hit the exclamation point GitHub command and you'll get all the slides, all the code. And we're going to be going through a ton of stuff. So I'm an architect at Trek10. So I work as a lead on technical projects, discovery, build, maintenance, security, and audit. Whole pipeline is stuff that we work with. And I've also got a lot of experience in serverless. I've been doing serverless since like 2017, so about as long as it's been a thing. And today we're actually not going to be using a serverless application because SAM is not, in fact, just useful for serverless applications. So what we're going to be looking at is a container-based application. So we're going to be running in Fargate because there's nothing in my container that requires direct device access, which means I don't have to use Elastic Container Service and run my own EC2 instances. Instead, I can run on Fargate. Awesome. So it's more serverless, not serverless, but it's more. And then we've got ECS managing those containers, application load balancer, and then on the back end, we have RDS Postgres. Love DynamoDB. The AWS simple table resource is really nice, but sometimes you need that relational power tool. And so that's what we're going to be using today. So that's going to be our application. And the real showpiece here is not the application. The application's maybe 50 lines of code, but what we're talking about today is the idea to production path. So you need to go from an idea or a feature request into code, into a reviewable state, like a real environment where people can play with it, and then finally into production. So we're using code pipeline, we're using code build, and we're using SAM, of course. SAM actually has 2 or 3 spots in this project because I use it to build the CI pipeline, and then I use it in the actual application as well. So for anyone who's not familiar with continuous integration, it's the idea of continuously putting all of your software together in one environment so that you can see how it all works together. The next level of that is continuous deployment, where there is no manual step in between code getting approved and code getting into production. Every step is automated and either gated with a simple code review or with automated testing. So this is the dream that you want to aspire to with a CI pipeline. You got your source control, so your GitHub, GitLab, code commit. You got your unit tests, building the application artifact, promote that to an environment, approve it, send it out to production, and then automatically validate production, because as close as you can possibly get to the production environment, you will never be as ingenious as your users about finding edge cases. because there's only a few of you and you might have millions of users that are all just pounding every edge case of your software. In this demo, we are going to be doing a lot less. No unit tests, no QA environment. This is not a how to do all of the language testing stuff. So I put little X's through all the things that we're not going to be talking about today. And now it's time to switch over for the demo. So what we're going to do first is we are going to copy up my code to S3, which is where my pipeline is triggered off of. So I have my Docker pipeline in US West 2. And so I'm going to kick that off. And then we're going to switch over to the AWS console, and I'm going to show you what exactly is going to happen as I push this out. All right, so we got to switch over to the AWS CloudFormation console. So just to start out, this is, of course, the CloudFormation console. Just so you can see there's nothing up my sleeves. The only things that exist in this whole region, so this is Oregon, is I have my CI pipeline, I have the repo for the ECR repository, and I have the service CI pipeline. So that's what I just uploaded that infra dev zip file to. So the service CI is taking the infrastructure and the container image and putting them together and shipping them out to production. So if we look in the outputs, this is actually a fun trick also in CloudFormation, is you can get CloudFormation to output the URLs in the console to things. And so I'm gonna hit that in a new tab. And then if you look at the outputs section here, using sub, I can put in the current region and the pipeline name into the URL. And then it shows up in my outputs. So I can just go straight to the stack that I want the CI for and hit up the code pipeline console for that. Really just a time saver. It doesn't actually do anything for your application, but when I need to find the pipeline, it's easier for me. So
yeah, I'm sure you're going to go into this a little more, but you've actually split out your pipelines, right? You've got a few pipelines here, right?
Yeah, so the reason that I have two pipelines is for this artifact promotion type of workflow. So I never want to build something and then promote something else to prod. Because once I've built it and tested it, I don't want to introduce other changes or potentially who knows, maybe there was a left pad came off of NPM and now I can't build my container for prod, even though I have a working container on dev, right?
Yeah.
So what's great is the ECR repositories have, they have a thing for, wow, this rendered really badly. So just trust me on this one, but that ECR repositories have the ability for cross-account access. So I can have my central shared services account, build my containers in there, and they stay in that repo. And then in my service account, I would build this hat market service CI. And so every account that has the infrastructure would be built off of the same container. And so that way I'm preserving that artifact as I promote up through my stages. So I'm more and more prod-like, reducing that delta. And so the one pipeline, you already mentioned I have the separate one, is the app pipeline. So what this does is this uses code build. And I'll just throw out the code build logs. So you can see that what it's doing is it's making an image. It's doing the Docker build. So you can see all of these steps, and then it successfully built a specific container image. Pretty standard. And then you can see that it was just built. And you'll note that it's not tagged latest. I'm tagging it with the artifact version. So this way, when I roll back, I don't have to wonder at that time what version of the latest container was actually latest when I pulled it. I have this unique name that I'm using, and that's coming off of the code build source control version. So this version is being preserved all the way through my pipeline. So now when I need to ask questions about, oh, what version are we on when this happened? What happened here? What happened there? I can actually see that and verify that, and that container image will still exist. Really nice.
Interesting.
And so I throw that into an image manifest.json and put that into S3. So you can see this was for the branch dev, and then here's my tag. And then I push it out to ECR. So there's my ECR URL, all very standard stuff. And then finally, I put my image manifest into S3. S3 is another cross-account resource because S3 has bucket policies, so I can allow as many accounts as I want to be able to access that image manifest. So again, artifact immutability across multiple accounts.
Yeah, that's actually a kind of an interesting point that we probably shouldn't gloss over, right? Having dedicated accounts, right, for each level of environment is definitely a thing you should be doing. And I wanted to back up real quick.
All one account.
Yeah. I wanted to back up real quick too. You mentioned a couple services, so far, code build, ECR. ECR, just really quickly, I won't make you go into too much. ECR is just a AWS style version of Docker Hub, kind of just an image repository central to your AWS account. It's not public to the public internet like Docker Hub is. And then code build. Code build's pretty interesting. You were doing some special commands up in code build too. So you wanna give a little insight into
So first on the ECR, this is the ECR console. It's a pretty straightforward console. You put images in it. It has a permissions tab, so I can allow other AWS account IDs. You can see here that I can allow other AWS account IDs to see my images. Very handy. And then you can also do lifecycle policies. So this is kind of my base lifecycle policy. So master builds, I keep the last 10. Dev builds, I keep the last 4. Staging builds, I keep the last 5. And then anything untagged gets deleted in one day. So this is just another one of those manageability things that way when I scroll through the images, I'm not scrolling through 500.
That's really nice.
And I'm not paying for storage for 500, right? Because I mean, it's not big money, but over time, like if you have a year of images, 2 years of images, and you're pushing to dev like multiple times a day, that's 600 images a year if you push just about every workday twice a day. So, and that's assuming that you don't have a team that's also pushing. That's just you. So that can add up. In the code build, I was using what's called a special environment variable. So if you look in the build details, this is the file, the build spec that's actually doing the build. So specifically, I was using this code build resolved source version. So this is in S3. This is just a short string that's like the version ID shrunk to 6 or 8 characters. If I was hooked up to GitHub instead, this would be the GitHub commit hash. If I was hooked up to code commit, same thing, git commit hash. So these special variables are always there for you, and I actually have this env command in here specifically so I could show those. So if you look in the build log, I think I might have to view entire log here.
There you go. I'll kick us over so you can log in private.
Oh, already good. So back in where was I? I was in Docker build, and I was looking in the build, and I was looking in the logs. That's where we were. All right. So if you go back and look at the very first logs here, you can see it's pulling in Python, all very standard stuff. But then this env command tells me all of the fancy environment variables that I have available to me. I get the build ID, I get what KMS key I'm using to encrypt things, I get my branch, I get PowerShell stuff for some reason, even though I didn't select PowerShell, I don't know why.
It's in the Amazon Linux image, if that's the
Yeah,
image.
I know it's in there, but like I only asked for the Python runtime, but I guess it sets the variables anyways. But tells me where my container credentials are, tells me the ARN of my code build. So if I want a unique thing for this exact build, I can use that. All these are really handy. But back to the pipelines. So this is only a part of the pipeline. This is building my image. And then the other half of the pipeline, I have what's called a multi-source pipeline. So on one side, it's taking in this image manifest. So anytime the image changes, I'm going to roll the pipeline. I also have a template bundle. And so what that is that's my CloudFormation templates to actually run the service. So this is the CloudFormation templates that are responsible for my VPC network, my RDS instance, my ECS cluster, my task definitions, which obviously use the container image. And all of that infrastructure stuff is also something that I can trigger changes off of. So what I get is if either of these things changes, I get that update. And I never have to do a like dummy commit up to my app repo to trigger a deploy, because all the things that should trigger a deploy actually will trigger a deploy. So semantically makes a lot of sense, and it makes my life easier as an operator because I know that if someone changes the infra or if someone changes the container, I get that deploy and it goes through the pipeline together.
Oh, okay. So you've actually got two things here now. So you could track the images separately and only update based off of changes that really affect either the code or the infrastructure.
Yeah, and these can be in separate repos if like one team is managing the infra and one team is actually writing the app, right? Or if they have different release cycles, you don't need to like get double approvals. It just makes things way easier.
That's awesome. Let me pause you right here real quick. This is sorry, a little housekeeping here. We're at the top of the hour. We haven't done this in since we started, basically. But you're joining us here today. This is AWS Howdy Partner. We bring on partners from the APN, and today we're meeting with Ryan Scott Brown from Trek10, who is walking us through how to build a very realistic and very detailed pipeline for automated deployments that utilizes SAM in some interesting ways that we actually haven't even gotten to the SAM part, which is cool because I know it's coming. And it's
that's next. That's right here.
And earlier we had Alex Wood from the AWS SAM team just give us an overview of SAM GA and what SAM is. So be sure and watch the video on demand if you missed that.
Yep.
If you're also following along, the links to the GitHub repo and the slides are in the chat. Let's take a look real quick.
Yeah, and all this code's on GitHub. Trek10 also has a AWS Quick Start for CI/CD, so that's even a level above this pipeline that I've got for this demo, because it natively supports all the multi-account stuff, natively handles a lot of the approvals and testing. It's really great. So what's going on here is now that I've got my templates in, so I've got my templates and my image manifest, we've transitioned into preparing the deploy. So we got our code build. I close out some of these tabs because this is going to get crazy. So this code build, if we just step back for a second and look at the build spec, so this gives us the idea of what's going on here. So I'm installing the SAM CLI. Awesome. I've got my image manifest.json. Super cool. I've gone into the CloudFormation directory for my ECS service. And then I'm running a SAM package. And what this is doing is it's taking a bunch of different CloudFormation templates, putting them all together for me, and deploying them. So if we check back in the CloudFormation console, you can see that there are now way more templates. So When we started, market service didn't exist. You can see the timestamp on here, 1753. That's 5:53 our time, so about 12 minutes ago. And this is also, these are all new, right? And each of these templates is separate, but what Sam did is it zipped them all up and put them in S3 and made them all available for me in this top level template here. So this top level template, what it's doing is it's using AWS CloudFormation stack. And so I have different stacks for RDS, for my network, and Sam is the one that actually did all of these uploads for me. So I didn't have to write my own script, didn't have to do that work. Really nice. So we've got our network, the network template is probably the most resources total because it needs 3 AZs worth of subnets, route tables, routes, route table associations, whole 9 yards. ECS cluster stack, way smaller. It's got a security group and it's got an ECS cluster. And we can just click on the physical ID, get out to the ECS cluster and see what's going on. So right now, looks like nothing. We're still in the middle of deploying, so that kind of makes sense.
This is a question I get all the time, though, Ryan. Is what happens if I have a VPC sitting outside of the project that I'm trying to deploy through CloudFormation? I think this is the answer, right? Like that you can reference that stack.
Yeah, this Substack technique gives us the ability, and I'll go over this a little more later, but it gives us the ability to decide: are we going to bring our own VPC in this template when we deploy the service, or are we going to use one that someone else set up for us already? And we have that option because each of these is a substack. So technically, I don't need this ECS cluster thing if a cluster already exists that I can use. Same thing for RDS. This RDS template is, of course, nice, automated database, don't have to worry about it, very easy, very cool. However, if someone's manually set up the RDS database for me already, that's fine, I don't mind. So what's going on in this template is I've got the DB instance. So I have my different storage, I have 50 gigs. And I'm actually using Secrets Manager. This is another one of those, as you go to prod, this becomes a critical technique. Managing your secrets and making sure that you're not putting stuff where it's, insecure or public or anything. So the really slick thing about CloudFormation is, of course, I can generate the secret right in the template. So I've generated the secret here. So you can see I'm specifying the strength and stuff. So punctuation, spaces, what to generate, how long it should be, and then what to put in, right? And then I'm just refing that right in the same CloudFormation template and throwing it into the master user password for the database that I'm creating right now. So just dead simple, like, I only had to do this in this template. I didn't have to manage the secret anywhere else. There's no other like, oh, I've got a manual step to like copy it out of 1Password, copy it into Secrets Manager, like all automated. Super nice. And then the last one is the application service. So looking at the resources, this might look like kind of a lot. So we have a couple of roles because we have to have different IAM roles for us to execute as. We have the load balancer, of course, and its listener. So this is for it to listen on HTTP. We have our task definitions. This is the part that's really the meaty part of this template, because these task definitions have a ton of different settings that are related to our app, and they use that container image. And then we have our ECS service, and this takes our task definition and some capacity information and puts it together so that we actually have running compute. Because if we just have a task definition, no container would ever run. If we just have the service and no task definition, it wouldn't know what container to start. So the service takes the compute preference, so Fargate in my case, the number of containers I want, which I've just set statically, the task definition, and then figures out how to place all of that on the ECS cluster that I'm working in. And so while I've been talking, a little long-winded, I'll admit, but we've completed shipping our service. And so if we look at our outputs, we have a handy service URL. So we can just
Yeah, I'm really excited to see what our service is. Like,
Oh no.
uh-oh.
That is the curse of the live demo.
That's
You know
right.
what I bet it is? I'm not asking for JSON.
Oh, no header.
Yep. So I'm going to take a screen share swap. I thought I could do it in the browser and be all fancy, but so you should see a terminal here.
There you go.
And there we go. So my inventory is empty, right?
Okay. Okay.
Wrong URL. Of course it does. Copy that address back in. What is wrong now? So in the live troubleshooting experience, we have, so what we're going to do is we're going to go over to the cooking show version of this. For the luck of the Irish, I have already prepared a version of this same demo in Ireland.
Nice.
So what we are going to do is we are going to change this over to my EU West 1 region, so you can see this handy dandy. And there we go. So we are working in EU West 1, and I really wonder what went wrong there. But anyways, through the magic of cooking shows, we have the working demo regardless. So when we, okay, so we're gonna head back to slides. So that's sort of the start of the demo. The demo is gonna get a little more advanced even. But we are gonna just tease that and then go back to talking about what actually makes this cool, right? Because hitting a JSON endpoint, getting a couple of lists, it could be more exciting, I'll be honest. So some of the things that went through to make this actually happen were CloudFormation change sets. So this is like a plan of the actions CloudFormation is going to do to my infrastructure before it actually does it. So I submit my CloudFormation template, and Sam does this for me automatically, and it'll submit the change set and then give me the option to approve it and decide whether I like it or not. And so what's great is if you don't like the changes, you can delete that change set, change your template up a little bit, and then make a new one. Really nice. The other distinction that's important, so Alex was using SAM deploy for all of his work there. So he would do a SAM build and then do a SAM deploy. And the SAM deploy would create the change set, change the CloudFormation stacks, and then actually edit my infrastructure. And instead, I'm using SAM package. And the reason that I'm doing that is because I need to take advantage of some really fancy code pipeline features. And what I can do with code pipeline is Sam will package the artifact for me, and then I can save that. So again, that idea of immutability and artifacts. I can say, okay, we're gonna save that artifact to S3, and then say code pipeline, create a change set for this, and then execute the change set. So instead of having to like run a container where, let's say, I'm in code build, so I have a build timeout limit, or running it on my laptop where like, oh, I close my laptop and then I don't see the deploy finish. CloudFormation is going to finish the deploy. I can trust that. But if I have some advanced, like some different workflows that have to happen where I have to deploy this CloudFormation stack, wait, deploy the next CloudFormation stack, then what's going to happen is I will have to like restart that workflow or just like wait and check back or keep my container running the whole time that it takes that CloudFormation stack to deploy. Whereas with Code Pipeline does all of the polling for me. It makes sure the stack exited in a good state, make sure everything worked nice. It's just much better. So let's see here. So that's the difference between SAM package and SAM deploy is without the pretty colors, you're a little bit sad, but you're also not around to watch it. So that's also fine. And then that multi-account thing that we touched on. This is where that quick start that we have, that enterprise CI/CD quick start really kind of starts to be a lot more interesting because it has all of these cross-account permissions already laid out for you, along with kind of a best practices account separation policy. So being multi-account lets you limit the blast radius. So like if you accidentally put a star in an IAM policy, the worst that star can do is affect everything in that one little environment, not affect the entire world in your AWS account, right? It also enforces stronger security boundaries. You have to engage cross-account access. So it's very explicit when you're allowing those boundaries to be crossed. And then it also splits out responsibilities better. So you can give developers their own AWS account and they can go nuts. And then as they kind of solidify those ideas, they get promoted through these other environments. And because we're using infrastructure as code, that's a very easy promotion process. And it's allowing time for approval gates like security review. So if you have to have someone manually review all the IAM rules before they go into the staging account, you can have that policy without making it so that every developer is just blocked on whoever reviews IAM policies, because that's no fun.
Thank you for assuming that it was an accidental star in the IAM policy too, by the way, Ryan.
Yeah, I mean, no one would intentionally do that, I'm sure.
Never. Never done it.
And so this is the pipeline. We already kind of talked about that separation. So for us, we are going with S3 as our source of truth. And that's just because for this demo, I just want to be able to upload things and just keep on going, And so let's see here. And so we have that separation. So we're transmitting the manifest across. You have the code pipeline. You got the, my favorite AWS service logo personally, the serverless SAM squirrel. And then you have those CloudFormation actions. So this ECR is actually via this manifest defining which container, and then the CloudFormation action throws in that container ID to the task definition and then actually gets it deployed. And the really interesting parts of this pipeline are that we also have a step function in here. And we haven't even gotten to that yet, but we're about to. So what the step function is doing is it's helping me with one of those processes that when you're just starting out doesn't seem like a big deal. But as your database gets bigger and more complex and has more kind of business partners that have stakes in that database schema, dealing with migrations becomes hard work. So what this step function does is allows us to deploy a new container. Where did I put that? Yeah, here we go. Have a new container just for migration. So this migrations v2 template is deployed while this Flask app v1 is still serving traffic. Then this migrations v2 container upgrades my database schema from schema v1 to schema v2. And app v1 is still serving traffic and no customers have noticed any interruption. Then I deploy Flask app v2 and it matches with schema v2. So now I've never accidentally deployed an application where the field in the database isn't there yet. So I'm sure that as you've evolved data models, you add a field and then you put the code in your application and then you deploy it and then you find a record that doesn't have that field and it hoses you. So
I think this kind of goes back and ties to the fidelity conversation we had earlier, right? Like the fidelity of the environment that you're actually deploying in and testing in and QAing in and UATing in and all those wonderful acronyms we use before we actually get software shipped.
Yeah, and so all of this is putting your migrations as code too. So now your application and its migrations live together and transit together through that lifetime. So that's why we have a step function in our pipeline, is because we want to deploy the migrations container, have the step function make sure my migrations actually happen correctly, and then have the CloudFormation action that really deploys my application with the new version, which is really nice. So the other thing that we've talked about and touched on a little bit is these CloudFormation substacks. And so I'm going to go do a little bit of a code walk in a minute here. And I see a question in chat about what type of state machine for Express versus standard. For this, I use standard. And the distinction for standard is that it may take a long time, and I care a lot more about the logging. The differences between Express and standard: Express has a 15-minute timeout limit that I definitely remember. And then it also has some differences in how the billing works, because it's pay for the length of the execution versus paying per state transition. So it depends is the classic kind of software answer, but it really does depend. And then the last thing I wanted to touch on about SAM specifically is the transforms that aren't just for serverless. So you have the simple table, that's a very serverless transform. You have step functions, that's a very serverless transform. But you also have these IAM policy templates. And these are just a really crafty little thing that you can use for any IAM role or IAM policy that you're gonna be working with. So if you take a look at the actual policy templates documentation, you can see that there's, I don't even know, this scroll bar is really small. And so you can see that there's, for a lot of these, a lot of different services that you would use with or without serverless applications, like KMS policies, you're using those all the time, no matter what. Code pipeline stuff, you're using all the time, no matter what. Secrets manager, you're using this all the time, whether you're serverless or not. EC2 copy image, that's not very serverless at all, actually. You can open an issue on GitHub about that to get that removed, I think. But the point is that all of these have parameters that they take. So see how they grab this table name for you and give you the common things that you're going to need to be able to look at and be able to operate with. So instead of having to like Google and find the exact permissions, or use the IAM actions document, or copy someone else's policy, or just put in DynamoDB : *, which I'm sure that nobody would do.
I have to say, one of my old colleagues, her name's Nikki Stone. She was interviewing one of the principal engineers here, Becky Weiss. If you've never seen Becky Weiss talk or know anything about Becky Weiss, go Google her. She's incredible. Nikki was interviewing her, and Becky was just on Twitch, handwriting IAM policies live, just from memory. She's a superhero in my mind.
I mean, we're not all Becky.
I'm not Becky Weiss, so I love that Alex and his team have made all of these policies for me.
Yeah, no, it's like that was actually one of the things when I first started looking at SAM, and I'm just like, oh, this exists? This is so handy.
Yeah.
Because sometimes there are like little details about writing the resources correctly or understanding which functions are important. And having that work done up front is super helpful. Because, I mean, people don't want to write resource star on purpose. You do it when you're like, I don't quite understand how to mentally model this yet.
Yeah.
And this is kind of another example of like, let's take a best practice and make it available to you by, getting these definitions done.
Yeah, exactly. And like the CloudWatch put metric, it has an asterisk, which is not ideal, but I don't have to remember the exact CloudWatch permission to do the thing that I want to do. I can look for the kind of summary of the thing I want to do. Like S3 CRUD is a really common thing. Like every app that uses S3, you basically end up writing this policy. And
yeah, and another thing I was saying in the chat is, feel free to open like feature requests and issues if you think there are policy templates that should exist that don't.
Yeah, for sure. But yeah, so these policy templates, super useful no matter what you're writing. And the other thing that I really, really love is the existence of the state machine. So if you look in my service pipeline, you have this nice state machine, and it's not a very advanced state machine. I'll just be straight. There's, I think, 2 states here. You wait for the task definition to become active because task definitions are actually eventually consistent. That latest tag is eventually consistent. Fun fact. And then you have the DB migration task. So what this does, it takes what security group and what subnets this is supposed to run in. Takes the security groups and subnets this is supposed to run in and just throws those in because those are given to the step function input, the execution input. And we can find that by looking for our DB migration flow in our code pipeline definition. If you look at my code pipeline definition, I'm invoking a step function, grabbing the ARN, and then I'm putting in the app service SG from this pre-migrate variable. And this is actually a stack output. So again, I don't have things that are hard-coded. So I'm not hard-coding my VPC. I'm not hard-coding my subnets. I'm not hard-coding my security group. I'm not even hard-coding my step function ARN because I'm pulling that off of the resource as it's generated. So this is all super dynamic. And this pre-migrate is actually coming from the namespace on my CloudFormation deploy. So when I'm executing this change set, after this executes, it grabs the stack outputs and puts them under the namespace pre-migrate. Super handy. The other SAM thing that's really nice is you saw I have all those substacks, and the way that those are defined locally, so if you look in my example code, you can see that I have vpc.yaml, the nice file name. And so I can just open up vpc.yaml locally, and here it is. And so it's got my VPC, it's got all this stuff, and that's great. But the nice thing is that I have this local path, so I don't have to have a build step where I'm uploading everything to S3. I just run SAM package in my build from code build like I showed earlier, and we can get all that. Just dead handy. And same thing for my ECS stack, same thing for my RDS cluster. All of this is like the same kind of bag of features that SAM is really useful for when you're developing a serverless application, but really it's useful for everyone in CloudFormation. So I'm really glad that that's included, and it really makes my life a whole lot easier. And then locally, if I were developing, I could have a SAM config toml, such as this one, and give it the S3 prefix, tell it what my stack name is, all that fun stuff, and then just run a SAM deploy. So if I'm developing my infrastructure in just a non-pipelined account, because I just want to go and iterate on that in the same way that you would use local invoke, you would just run SAM deploy locally and just deploy for testing. Very Very, very nice. And so that's the kind of basics for what Sam is doing in this project. And so now what I want to show is the part that actually involves the step functions. And this is a Python project. So the language is Python. It's hopefully the application sort of, I don't want to use the term self-documenting because if you don't know Python, but hopefully it is close enough to English that it feels like you can read it and understand it and be able to kind of go on with your day, right? So, for example, I'm using a SQL Alchemy ORM hats with the hat store because this is the Howdy Partner show. So we're going to be selling 9 gallons, 10 gallons, everything for your head covering needs. And so this has a 2 dictionary, so it grabs the UPC, got to have a capacity, got to know how many gallons your hat is, a more general description, and then the stock number. And you can see stock's an integer up here. So that's a pretty standard kind of ORM thing. If you're coming from Java, if you're coming from Rails, you know, I really hope that looks familiar enough that you see what's going on, because the important part here isn't the language. The important part is dealing with our data, our data here.
Real quick, Ryan. What is ORM? What is that?
Oh yeah, that's the object relational mapper. So in my database, everything's represented as a table, and then there's just a bunch of rows in the table. And then I need to pull that into an object so that I can do, you know, nice object-y things. That's a computer science term, I'm sure.
It works for me.
Yeah, and so you can see that my ORM here is meaning I don't have to write SQL. I just run session.query for hats, and give me all of them, please. And then throw them into dictionaries, and then throw my hats into this inventory JSON blob. So that's, you know, the get. I have a post as well. So, you know, I grab off of the body incoming, and then I add that to my database session, I commit it, and then I close out. And then I have a delete hat in case someone, you know, puts up hats here that are not appropriate. And then the last one is just this health check endpoint. This is for load balancing, just so that load balancing has something to check to make sure my container's happy. So that's really the whole app. That is all the Python code that runs my application in 91 lines. The more interesting part here is the migrations. So I'm using a tool called Alembic. Languages often have versions of Alembic. I'm sure Alembic is stolen from somebody else. And I don't believe there are any new ideas under the sun anyways. So, and Alembic gives us an upgrade and a downgrade function so that we can make sure that our database schema matches what our application expects. So we talked about that schema as code principle here. And you can see that I'm doing the same thing. I've got the table hat, I've got a column, suite, I've got capacity, description, stock, and UPC. And UPC is my primary key. So this is a, you know, I would say pretty standard database schema for if you're just doing inventory of something. And then the downgrade, it just drops, you know, drops my hat. And the way that this runs is you run Alembic upgrade against your database. So where that happens is actually in the ECS container definition. And this is a rather, you know, a rather common pattern for just running something one-off is you can use ECS to run a container, and then in the task definition, you can just put the command that you want to run. So Alembic upgrade head is what I want to run.
Now, this might be a stupid question, Ryan. This is the container that is run as part of the step function, right? Not
Yep.
the container that is actually running the service.
Yes, but they both use the same image. So they are the same artifact. They have different entry points. So this one has Alembic upgrade head.
Okay.
And then if I look at my regular task definition, the command is Python 3 app.py.
Ah, I see.
So you can see how like all of this has been the same. Like
Yeah.
all of this is the same artifact. My container build step is the same. My dependencies are the same. My version of SQL Alchemy and Alembic are going to be exactly the same. So it's all going to be the exact same code running in both of these definitions. So again, we're going back to that artifact immutability, right?
Makes sense.
And so now what we're going to do is we're going to go and find our Irish internal server error, you say. All right, so now I actually do have to go and debug this. I may have continuously deployed something broken. This is what happens when you don't write tests, kids. All right, so if we go to our cluster, go to one of our tasks. And find out what has happened.
Always something bad, never something good.
Let's see here. So my JSON well formed?
Oh, let's see.
I think that looks good.
Yeah, you get quotes. Nothing nested that shouldn't be nested. Ah, it looks fine to me.
Interesting. So the error that I am getting is, here, I'll just copy it into the terminal window just so that everyone kind of sees what's going on here.
Oh.
Is I'm do this incoming.get capacity, getting a none type.
It's null. My favorite. Yeah, I was gonna say maybe that dash data should set application JSON typically, right? I would think.
You would be wrong, and we would
Yeah.
we would both be wrong there. And if that's what was wrong in my other region too, that would be kind of funny. But anyways, here's our 9-gallon hat.
There we go.
You know, your standard. You know, gotta have a 10-gallon cap in here.
I only have one complaint with the hat store so far, Ryan. I think it's amazing, but I do have a complaint. Some feedback. Okay. I don't see any Vans options.
Okay. All right.
That's a big miss for me personally. Oh, there we go.
Yeah, oh.
I feel complete again.
We only have 3 of those in stock though, so.
Okay, that's fine. I don't want these getting out too much, getting too popular.
All right, so that error was just user error on my part. So in the future, I should probably handle that error a little better. But so here's our inventory in our Irish shop here. So you can see we got our capacity description, stock, and UTC here, or not UTC, UPC. So what we're going to do is we're actually going to open up our app, and we're going to add a field. we're going to add image link. And what this is going to give us is a new field that if we deployed our application without doing anything else, this would break. Because I would be trying to make an image or make a hat with an image link that wouldn't exist, right? And that attribute wouldn't exist, and this would raise an exception. So what I got to do is add an image link field. And oh geez, what's the revision, not version? Not me. So now, if I run my git status, you can see that I've added a new image migration, right? And so in my image link field, I don't have an upgrade action. What I'm going to do is I've tested this ahead of time because of course I did. This is going to be the Alembic migration to be able to add this column. So see, I'm adding a SQL Alchemy text type. I'm adding an image link here. So this is the entirety of the work that I need to do for my DB migration. So save that. We're of course going to do git add for image link field, and then we're also going to add all the stuff that I changed. So I added the image link, I added the image link in the dictionary, and then I added it as the create attribute here, right? And so now I'm going to deploy. Remember, we're not actually using the US West 2 version here. So we need to swap over to EU West 1. And so you can see I'm just uploading it to the bucket in that region that my pipeline is going to trip off. All right, so there we go. So now we're updating or uploading our application. And then we need to head over to EU West 1, and we want to hit code pipeline, right? And we're going to swap over our screen share to our wonderful code pipeline application window. And in the time it took me to switch that screen share, my pipeline actually started.
Nice.
So here we go. And we're going to open up the build project. Again, just as like kind of a nothing up my sleeves, you know, you can see like all of the build details. This build spec is exactly the same as the one in the other region. And I'm starting to think the one in the other region, the reason it didn't work was actually me. Because I didn't set that content type, got myself into trouble, but so life goes. You can see that the repository URI gets set here, you know, with the right region, all that's lovely. And then if we look in our logs, we're already on step 3 of the actual build. So if we take a look at the phase details, all of these phases are just dead quick. So you can see, you know, provisioning took 20 seconds, the build took 39, and the post build's probably going to take another 20 just to get the Docker push. So you can build these pipelines to be extremely fast. Again, it's about, you know, optimization, parallelizing where you can, especially because if you can build your container and run unit tests at the same time, sure, you pay the same for compute, but in human time, that's just less time I have to wait. Love that, right? So that's super nice. You can see our build's complete. And you can see this pipeline for the image build is going to exit in a second here. There's a little bit of a lag between the code build finishing and code pipeline getting the callback, which sometimes is kind of annoying. Mostly just for impatient people like me, but. And you can see that our next CI pipeline is already kicked off. It pulled in our infrastructure and our application, and we're already off to the races building our SAM template for our ECS service and getting that uploaded to our AWS account, right? And in a minute after we see that go, this is where that step function thing happens. So again, you can see the use of parallelization where I don't need to be waiting for stuff, right? So I've already deployed my migrations container. And then while I'm waiting for the step function to deploy my migration, I can also be creating the change set that is going to upgrade my app service container. So again, parallelism and being able to just do multiple things at the same time so that to the human, it looks fast.
I know we're not doing testing in this demo necessarily, Ryan, but do you have any advice for people? This is one of the areas that gets really sticky, right? Where you push a schema change out to a database. Do you have any best practices you could share around, like, do you have a separate database running that gets that change first, and then, once that all checks out, you push to prod, that type of thing?
Yeah, so this is another one of those nice things about Alembic. So Alembic has this notion of heads, which are different kind of pointers to different versions of the database. So in a real infrastructure, I wouldn't be using the Alembic default head.
Got it.
I would be using the Alembic dev or Alembic prod. So that way, I can have as many migrations as I am stacked up, ready to go to dev, and they're going to dev every time someone commits. Okay. And then on the prod head, I haven't promoted it. So I can then promote the prod head at like whatever time my DBA says is appropriate. So that way, the prod head is running those same dev migrations, but just because I run a migration on dev doesn't mean I have to run it on prod. And because Alembic downgrade exists, I can decide a migration I ran on dev, I never want to run on prod. So I Alembic downgrade the dev database and then delete that migration.
Totally makes sense. Yeah,
this is like partially a tooling thing. So Alembic has this. All your other database things have it. There's versions of Alembic that are available for just about every other major database except for DynamoDB, because DynamoDB expects you to do those migrations in the application. And Dynamo doesn't have those like hard schema constraints that you have in Postgres, which is why those database migrations have to exist for Postgres. But like for Dynamo, what I would do is I would just get that image link property, and if it's empty, just leave it empty. And then when I write, I would write the correct schema. That's what I would do in Dynamo, but I can't do that in Postgres.
Yeah, a lot of NoSQL options. This migration thing kind of goes out the window. You don't have to worry too much about it. Now you can like sour up your data really fast too.
If you're not paying really close attention to what people are changing about what they're writing to the database, you can get in big trouble real quick. Yeah. So you can see our SAM build has completed and our CloudFormation change set is complete. So this is our pre-migrate. So that's pre-database migration, of course. And in the input, you can see that the image for the application and the image for the migrations container are different. And this is what enables us to spin up the migrations container separately, run those migrations, then update the application, because these are separate params, and so they're handled separately. And so that's kind of the crafty thing at the heart of like why we need step functions for this at all, really. And so you can see that this already succeeded. Just gonna clean up tabs. Otherwise I get 50 tabs deep and I'm in real trouble. So now we can see our change set that's going to actually make the change to our service is running now. And if you look at the input here, same image for migrations and for our application. So this means that our migration will have completed because of the way that we're doing ordering. We won't deploy this change set until after my step function to do the migrations is actually finished. And if this were to fail, the step function would fail, and then I wouldn't deploy the change set. And then I would probably call my DBA because I'm not that good at Postgres. But depending on the size of your team, you might or might not have somebody to call. And so here you can see the step function actually running. So visually, there's not a lot to look at here. You know, we're waiting for our task definition to be ready. We're running our DB migration task, and then we're done. That's all we need. But if you look at the DB migration task, you can see that that's pulling in the app service and private subnets that are being filled in from my stack outputs. And
that's all for database access.
This is, yeah, because I can't, I don't want to make my database a public IP.
Right.
So I put it in the private subnets, and I need to have a security group on my container that allows me access to the database. So if you look at the hat market service and look at the outputs, you can see that the subnets are all coming out, and so is the security group. And so that's getting pulled in by the code pipeline, and then eventually getting put in here in the step function. And so our change set's ready, and now we're just waiting for the database migration to finish out. And if we hit that curl again for our inventory, you can see that our image still isn't in this return. And even better, you can see that it hasn't broken anything. So like our application's still accessible, even though that field exists in the database. Our application's not yet aware of it, but our application is okay with having fewer fields than are actually in the database.
Yeah, it's usually additive changes are really are pretty straightforward most of the time.
Yeah, well, so what you can do in the event of delete-based changes,
yeah,
Alembic has facilities for those for doing multi-phase upgrades. And so what I would do is I would have like a little intermediate where I would do the additive change the application to not use the thing I'm deleting anymore, and then push a migration that drops the column that I'm getting rid of. So if you break it down small enough, like you're able to do these changes in a way that's safe. And so you can see that these DB migrations just finished out. So we have our successful step function, our successful change set, and then out goes deploy phase 2. So if we look at our hat market service and the event logs, basically everything finished up super quickly. So that's 52, you know, we're at 53 now. So that took about 20 seconds. And the thing that's going to take the longest by far is this ECS service, because it has a drain time of 30 seconds on these hosts. And so what you can do is, because you can control that drain time, if I was really confident that people wouldn't have long connections, I would bring that down. 30 seconds is a pretty safe drain time because I know that nothing's going to last longer than 30 seconds in this app. And if it is, something really, really went wrong. And then if we look at our actual ECS service, we'll actually be able to see both versions of containers kind of running in harmony here. So if you look under tasks, you can see that V1 of our app and V2 of our app are running together. And if I were to look in the target group, it would probably show all of these as healthy. And then it's slowly draining them off. So now you can see image link is there. Oh, you actually can't see that.
Yeah, we can see your browser.
Yeah. All right. So now you can see.
Now we can.
Image link is there. I actually see an old version on the screen here. Do you see the JSON with the image link filled in?
We see null.
Yeah, but it should be, I mean, filled in as in like existing, you know?
Yes.
Yeah,
Yes.
it's there.
Okay, cool. I just wanted to make sure. And so now we can also do that same post. And what we're going to do is we're going to add a new and improved Vans baseball cap. We're gonna bring in about 70 of these guys. And then we're gonna add our image link. I'm just gonna grab a random. I could just grab a random image. All right, and that's kosher to put on this stream because it's Zappos and you guys own Zappos. So there we go. We see our image link come back, and we have the correct image of a set of Vans sneakers that you can wear on your head.
Actually, really funny that you say that. Oftentimes, for whatever reason, I don't know why, the Twitch stream will ask us to put shoes on our head to prove that we're alive. Like, that's seriously a thing. It's happened to me multiple times. I have no idea why. Alex, are you looking for a shoe? Is that what you're doing? I figured you.
That's very strange.
Alex, you're clutch, man. Okay, sock. Yeah.
Clutch. All right. Great work. I see one question in the stream about, as part of CI, do I use the Docker image ECR scan on push? The answer is generally yes. For this demo, no.
Yeah.
But most of the time, the answer is yes.
And shout out, because we are, Eric and I are partner solutions architects. We have partner products that are built to help with vulnerability scans too.
Also,
like Sneak, who will be joining us at some point on the stream in the future. So
yeah, gonna be sneaking on here. The one gripe that I have with image scanning is that you can't set it in CloudFormation. Just brings a tear to my eye. But yeah, so that is the main part of the demo. I really wanted to get in the step functions and just how Sam can, even if you're not starting this greenfield serverless application where everything is VTL to step functions to Dynamo, as much as I'm sure Richard Boyd would love to see every application be only that, because
only VTL probably.
He is a principal VTL engineer.
Well, he's not here, so
yeah, exactly.
So
there are no rules.
Yeah, so regardless, Sam is super duper useful for that. And then the last thing that I kind of want to shout out for is the AWS Builders Library, which is the Amazon provided, written by some of the absolute best engineers in the world about continuous delivery and safe hands-off deployments. Both of these are excellent, and I highly recommend you check them out.
What just recently launched too, Ryan, and I think this would, I'm gonna push you a little bit here to maybe, and you may have already done it actually. I have no idea. I shouldn't assume that you're not involved in this already. But we just recently launched an AWS Community Builders program too, for white papers and things written by community members. Because we have a pretty, like, this is another show that I'm involved with too. AWS Community Voices with our Community Heroes and AWS Heroes programs, which, you should totally write something for one of those. Just saying.
Yeah, I mean, I write a ton of blog posts generally. Like the Trek10 blog is just rife with, really great blog posts. Some of them I wrote. Most of the really great ones weren't written by me, but the Trek10 blog has a blog post actually about this enterprise CI/CD quick start
Oh, nice.
and explaining not just, the obvious stuff like this is why CI is important, but this is why we designed this quick start in this way. Because a lot of the hardest parts of getting CI into an organization is making sure that everyone understands why they're going for CI, and most importantly, like why it benefits them. Because people aren't going to just use the pipeline that that I build for them just out of the goodness of their hearts because they want to make me feel happy inside that my pipeline is executing, even though it does make me feel happy.
You don't do tech changes by guilt. That's
No, I'm a very carrot based
okay.
consensus builder. So I really love what if you just didn't have to do this and could just go do like literally anything else? Wouldn't that be great?
Words to live by.
And people would, people sometimes are like, oh, but I can do this, more accurately or something. It's like, no, you're not going to be more accurate. Like the only difference is you're angrier than the computer, I mean.
Yeah.
Because computers really thrive in those like dull, repetitious, extremely detail-oriented, high vigilance tasks. Because for humans to be able to succeed in those environments, we have to, A, not be doing it for 8 hours a day, just straight. B, we have to have really good checklists and a really good understanding of our system. And C, we have to not have anything better to do. Like, I think that, for a lot of things that people do manually, there is another activity they would rather be doing. No one is really getting up in the morning like, all right, I want to copy these build results over to a new S3 bucket manually, click and drag.
Well, I think also as you flesh this out too, you get the sort of collective wisdom of everyone who went into developing it, and you start to get a lot of interesting twists on that checklist or details that would not be immediately obvious why they're important, but oh my, when it wasn't there was a problem one day.
Yeah, and like people
standing on the shoulders of giants.
Yeah, and people will go off checklist because they get distracted. You get a phone call in the middle of your deploy, and you miss a step. That can be really bad. Computers don't get another call. They're just hanging out there executing your change sets. And
they do not tire. They do not get distracted. They do not stop.
Okay. Yeah, and I mean that's great. Like until you start attaching weapons and turning them into like liquid metal.
Yeah, we're going to Terminator world here.
Yeah. Yeah. So yeah. Okay. So that's the real like motivation for so much of what I do is that like tool building and making things more efficient and making people's lives easier, which in the enterprise translates to less errors, less like, oh, so and so's on vacation so we can't deploy, like all those kind of normal problems.
Yeah. But
also it just translates into a better day. Like it's great if you don't have to like, oh, got to come in and do the deploy this morning, and then it's just not something that you look forward to in the same way as if you can say, oh, I'm just going to push this code, and then it's immediately going to go out to users after it passes the tests, and I get to not worry about it because I have a really reliable way to push these, features or, bug fixes or whatever out right to my users instead of waiting for the quarterly release, the annual release.
And I would add, and I think it can be review if you've been doing CI/CD a long time, but when you have that tight commit, test, release cycle and you're releasing in small batches, the releases get easier and more reliable.
Yeah. You're doing it a lot.
When you go to the monthly release cadence, there's a lot of stuff backed up that can go wrong. And it's really advantageous to have that thing that gives you confidence to release often, because then the releases actually get more reliable, not less.
Yeah. And you don't have things where, oh, I did that database migration in the first week of this release cycle and then totally forgot about it. And now I forgot about the special thing I have to do for my manual prod deploy at the end of the month. Like, who among us hasn't forgotten that, right? Like, I've definitely taken down production forgetting what really should have been an automated step that I didn't automate because I was like, oh, it's not that hard, pish posh. So yeah, I mean, the whole CI/CD thing, CloudFormation is a huge enabler for Trek10 and our clients. SAM is just a real like nice wrapper or kind of pre-processor around a lot of CloudFormation stuff. Like, I've been writing CloudFormation for years, and I've been writing SAM for a lot less, obviously, but a lot of the things that for me were things that you have to learn and like build scripts for and really kind of do the work. Someone starting today can just download SAM and say, okay, give me a Lambda function, include this template that I was given by a teammate, include this other template, write this IAM policy for me, and just fill in the table name, please.
Well, and I would even go back and to the earlier demo and point out, so the example from a teammate, when we go to SAM init and the ability to run from a custom location, if you have private GitHub repos within your company, for example, that you have access to from your developer laptop, that is completely valid as a SAM init location to use as a custom location. So it's going to attempt to get cloned from your account, and if you have those credentials, then you can solve this once, get those best practices in place, and then share it with your teams. It doesn't like you can also share some things on public GitHub and share it with the world, but if there's things you need to share just within your company, you can absolutely do that.
Yeah, of course. And the nice thing is that Cookie Cutter, which is what SAM uses under the hood, has like a spec for not just filling in code, not just filling in project structure, but you can fill in readmes, docs. You can add hooks that register your service with something else. So like it'll get auto added to a wiki. There's all kinds of stuff you can do inside of that Cookie Cutter framework that you can make starting a project as low friction as you can imagine, because you don't have to create a new Python package. You don't have to create a new Ruby, bundle environment. You don't have to, set up unit tests or integration tests. You don't have to do all this kind of stuff because you've done it in the Cookie Cutter. And then when someone inits a project, it just fills in everything from the Cookie Cutter and you're good to go. So for really small microservice teams, you can have a base service that's a Cookie Cutter, and people just SAM init the URL of that Cookie Cutter project, and you've got a service that's ready to deploy, even if it only says hello world.
Just that implementation details.
I mean, we did all the hard part.
It's actually a lot, and it's not even a joke. It's actually a lot of really valuable heavy lifting to do a lot of that sort of not direct value add infrastructure setup, initial scaffolding, and then to be able to say, like, I can jump, like, the nice thing about the Sinatra example is I'm just writing Sinatra. I'm not really thinking about the fact that I'm operating in a serverless environment. I'm just writing code.
And would this be an AWS event if we did not say undifferentiated heavy lifting a couple times?
There you go. Yeah, I think I
We're
laughed.
raising the content bar here.
I laughed because a lot of that work just goes overlooked and unappreciated. But yeah, so we're getting here to the end. We need to start wrapping up. I want to give you both a chance to give us some highlights and areas that you would suggest to go for next steps. I know, Ryan, you just did that a bit, but Alex, I want to give you that opportunity too. But before we do, Eric, do you want to tell us about the show? Like, why should you watch Howdy Partner? What's up next? I'll pull up the calendar for you too, so I can tell you what shows we have coming up. But give us a rundown. What is Howdy Partner for anybody who's never watched before today?
Sure. So if you aren't too familiar with Howdy Partner itself, so the show is basically here to highlight some AWS partners that are building on top of AWS. There's many different companies using many AWS services. We're going to continue to have more partners involved, ranging from many different topics. It could be edge computing, serverless, which everybody loves. We're going to continue to try and bring you the best content possible. It's an open area for questions, so you could come over here. It doesn't matter what type of level you're at in terms of using AWS. It could be 100 to 400 level. You're here to learn, so the floor is open to any questions that you have moving forward.
Yeah, and in regards to content too, that's a great point of if there's anything that you are interested in that you are not seeing on this show yet that you want to hear more about, please hit us up.
Yeah.
On all our social media channels here. You can absolutely give us some feedback.
Yeah.
Our next, go ahead, Ryan.
And you can find me on Twitter. Alex is also on Twitter. I saw a question about if we're hiring. Trek10 is definitely hiring. And if you are a fan of, we're 100% AWS, so we don't do multi-cloud workloads. We really are focused on, like I said, that serverless and IoT space. So we like to think we're one of the best in the business. We made Premier Partner, so AWS at least thinks we're pretty top tier. And we are of course hiring. Trek10 and the rest of the cloud industry is growing and just scrounging for every bit of talent we can find, because there is just so much left to do. There's so much that's not in AWS or not in the cloud at all, not in any cloud, and people are just kind of beating down the door right now. So if you are looking for a job in cloud generally, regardless of your level, I would encourage you to, you can hit me up on Twitter, you can hit up the Trek10 jobs page. But if the kind of stuff that we've been talking about is exciting to you, like we would love to have a conversation for sure.
Love it. Alex, is there anything you wanna summarize or
yeah,
point?
I think the biggest thing is, if you haven't had the chance to try SAM yet, download the SAM CLI, and you can literally say run SAM init, pick a language you like, pick an example you like, SAM build, SAM deploy guided, and I mean just you're up and running. I think the moment for me with a lot of tools where you really start to learn quickly and really iterate quickly is the first time you get something deployed and there's something working, and then you're just building on top of that. And with SAM, you can be at that moment in 5 minutes.
Yeah, so, and it's also just
once you're out there, you're just writing code, you're just iterating.
Yeah. And it's just so cheap to get started too, because Dynamo, paper request, Lambda, paper request, API gateway, step functions, just get in there and start hacking.
Yeah, that's all great advice. I saw that there was a question about CDK versus SAM, which we unfortunately don't have a lot of time to answer left. I think I will use my blanket statement that I use for partners, for all the tools and services that we have at AWS. There's a use case for each of them, and just go research, find out what one can do, one can't do, things that they do better, and commit to learning one of them. Pick one. There's really not a wrong choice that you can make in a lot of these cases. So just experiment. Play with all these things. Figure out what each has that you desire. And I'm gonna plug Alex over here too. If there's something that SAM doesn't have that you need, go open an issue on GitHub, because that's how we implement new things in SAM. So
yeah. I mean, I see a lot of CDK, a lot of SAM. They both work. They've come from very different approaches, but they both ultimately end up with cloud formation and running infrastructure, which is really all I'm looking for.
So I'm going to wrap us up here. We've had a lot of episodes so far in Howdy Partner. Go back and watch any ones that you missed. They're right here on the Twitch channel. We've got another episode coming up on August 12th with Splunk. I mean, everybody loves Splunk, right? So that should be really cool. Be sure to tune in for that. We do episodes mostly Wednesdays and Mondays at 2 p.m. I don't know why I did that backwards. Mondays and Wednesdays at 2 p.m. Pacific. But before we go, I'm going to let Eric pick this because this is his first stream. We got 3 sign-off phrases that we like to use here on Howdy Partner, and I'll let you pick which one, Eric. We've got y'all come back now, you hear? We've got happy trails, and we've got, oh man, Mo, I need your help. What's the third one? I don't know.
Is it Sam Build?
Yeah, it's Sam Build, actually. Yeah, it is now, apparently. I don't know, man. Like, I think the actual meme of the sign-off is that we always forget one of the sign-offs. That's actually, giddy up. It's giddy up. Mo got us. Okay. So, Eric, how are we going to sign off?
I think I'm going to go with Happy Trails. I think I'm a Happy Trails guy.
Good one. Good choice. All right. So on 3, we'll all say Happy Trails if you're in. Alex, you're in? Okay. With all the puns that you gave us, I feel like you can do this.
Shouldn't be too punishing.
Thank you both for joining us, seriously. And go check out Sam. Go check out Trek10's work with the Enterprise CI/CD. Go read Ryan's blogs, all the things with Trek10. Go check it out. It's awesome. So 1, 2, 3. Happy Trails. Oh, and Richard Boyd just got here. So, thanks for joining us at the end, Richard.
Thanks.
Bye, Richard.